Hello, everyone. My name is Xiolmara Martinez. I am a first semester graduate student here at Loyola University pursuing my PhD in chemistry. I got my undergraduate degree in forensic science, also here at Loyola University, Chicago. My presentation is going to be on the determination of illicit designer drugs and their metabolites in wastewater. First off, drug laws in the US are enacted to regulate the use of specific chemical compounds. Designer drugs are made to have similar properties to known hallucinogenic or narcotic substances, but have a slightly altered chemical structure or molecular formula. This overall changes their identity to avoid regulation. Because they aren't regulated in the US, they are technically legal to use, and people get their legal highs. The European Monitoring Center for Drugs and Drug Addiction, the EMCDD, monitors the sale and distribution of many illicit designer drugs that are sold through the internet. The EMCDD estimates that there are at least 651 websites that sell different designer drugs. The immediate goal of this research was to determine the extent of selected designer drugs used in the Chicago area. The two drugs of interest were MT45 and fentanyl. This would be fentanyl, and this figure over here is MT45. MT45 is a synthetic opioid that was scheduled as a Class A drug in the UK as of March 2015. And is banned from the Czech Republic. Currently, MT45 is not regulated in the US. Recently, however, the Canadian Controlled Drugs and Substances Act was amended in 2016 to include the substance as a Schedule I drug. Fentanyl is also an opioid that is 40 to 50 times stronger than heroin and 100 times more stronger and potent than morphine. This is regulated in the US, but much effort is made to make analogs of it. The opioid epidemic in the US. In 2016, there were 20,100 fentanyl-related deaths. Some heroin dealers mix fentanyl powder with heroin to increase potency or compensate for low-quality heroin. A milligram, which is about the size of a grain of sea salt, is enough to cause an overdose. There have been so many overdoses that Narcan is carried by almost all paramedics and police. Narcan is what they give to people who have overdosed to reverse the symptoms, to bring them back. My methods to collect my samples, I collected wastewater from the MWRD James C. Curie Water Reclamation Plant in Des Plaines, Illinois. I then took that water and I filtered it through microfiber filter paper and adjusted it to a pH of 2 using 37% hydrochloric acid. This filtered sample was then gone through solid phase extraction using the MCX cartridges. The cartridges were then conditioned using 6 mils of methanol, 3 mils of molecule water, and 3 mils of acidified water. The eluent is then evaporated under ambient conditions using nitrogen gas. The resulting residue is then reconstituted in methanol for GCMS analysis. Low-res fragmentation mass spectra of drug standards were acquired on a GCMS here at Loyola University in Dr. DiFrancesco's lab. Then unspiked and spiked influent wastewater samples were acquired on a GC time of flight at the NIH-NIGMS supported biomedical mass spectrometry research resource at Washington University in St. Louis, Missouri. A 3-meter column was used for separations. The initial temperature of the gradient was 40 degrees Celsius, and after 2 minutes was ramped up to 300 degrees Celsius at a rate of 10 degrees Celsius per minute. The temperature was maintained at 300 degrees Celsius for 4 minutes for a total runtime of 32 minutes. The source temperature was maintained at 280 degrees Celsius. Here we have the full scan GCMS of fentanyl eluting at a retention time of 10.4 minutes. This figure right here. And at the bottom, we see a full scan GCMS of the MT45 eluting at a retention time of 10.6 minutes. After that, we grabbed our extracted ion chromatograms of the M/Z 257 ion from the GC time of flight MS analysis of A, the MT45 standard, and B, a wastewater influent sample. The figure 4 at the top is extracted ion chromatograms of the M/Z 189 ion from the GC time of flight mass spec analysis of A, the fentanyl standard, and B, a wastewater influent. Figure 4 at the bottom is extracted ion chromatograms of the M/Z 245 ion from the GC time of flight mass spec of A, a fentanyl standard, and B, a wastewater influent standard. My results. Based on the chromatograms of the fentanyl ions of the M/Z 189 and 245, fentanyl could be identified in the unspiked Curie sample, eluting with a retention time of 21.9 minutes. MT45 is observed to elute at approximately 22.4 minutes in the wastewater samples based on the detection time of the M/Z 257 ion in figure 3B, which is this one right here. Based on this, we have detected MT45 and fentanyl in our wastewater influent from the Curie Wastewater Treatment Plant in Des Plaines, Illinois. Our next steps, we will explore more LC-MS methods for analyzing these and other designer drugs and wastewater effluent from the Stickney Wastewater Treatment Plant, which serves a much larger population of 2.3 million people, whereas Curie only serves a population of 264,000 people. I would like to give a special thanks to the Paul Chiarelli Lab and the James DiFrancesco Lab, and to all others who have helped with this research. And I would also like to thank Loyola University and the Chicago Chromatography Group for allowing me to present today. Thank you.